There is just one participant. Okay, I'm starting. Maybe they will see the recording. So, okay, a second. So today we will look into one string hashing, KMP, and Z algorithm. So all the three are basically basic string algorithms, which are mostly uh, relevant to competitive programming. So what is a string hash? Like for a string, basically we are assigning, suppose the string is a, suppose the string is a, b, c, d, x, suppose. So we are assigning a number to it. So which will be calculated by a function, which we will come in the next one. So we uh, uh, like suppose a, b, c, d is given. For A, we assign a number 1. For B, we assign a number 2. For C, 3, and D, 4. Just like in binary 1, 0, 1, we take this as 2 power 0 into 1. This is 2 power 0, 2 power 1 into 0. And this is 2 power 2 into 1. So is equal to 5. Just like this, we will calculate a string as S of 0. So this is calculated like for A we assign 1, B to 2, and it goes on till Z to 26. So till now, is there any doubt? You can write in the chat box. Okay, so it is fine. And like the numbers will be quite high, so we can't take it into a 64-bit number. So we take a mod m, and m we generally take it at 10 power 9 plus 7. So this is string hashing. So this is a problem. Can anyone suggest me, like there are n strings s1, s2, so on till sn. So we have to group, like suppose a, b, c, d, e, f, g, I suppose, and this is a, b, c, d. Like we have to group same strings in a group. So how do we go about it? Anyone can unmute and speak or write in the chat box using hash. Like okay, I will say how to do it. So like we assigned a string a number. So what we do is, suppose this is assigned number a, this will also be assigned number a, because the formula is independent of the location, and this is assigned b. So now suppose the numbers we get are a, b, so on till a. We will now sort it a, and so on, b, and so on, so on, so on. So this will be grouped as the same string. This is the problem, and the complexity will be O of n log n for sorting, and for hashing, O of n cross m, as we are given that the strings are not longer than m characters. So is it clear, or should I say it again? Okay. So like we said about hashing of a string. Now suppose I am given a problem, like suppose string is a b x y z, and s2 is suppose bx. So bxy. Suppose I have to check if s2 is present in s1. So can anyone suggest me a naive algorithm of how we go about it? So I will go over it faster. So abxy. So we see if we can find the string from here. So we check first the okay. So a b x y z suppose, and b x y. So in S1 we check for the first location, we check if it is possible if it starts from here. So it cannot start because a is not equal to b, and now we go here and we find that bxy is same as bxy. So uh, we got s2 in as a pattern in this string. Now we go here, we don't find it. Now we go here, we don't find it. Now we go here, we don't find it. So the algorithm will take O of suppose this length is n and this length is m. It will take O of n cross m. This is not a very efficient algorithm. So what we do is uh, we can uh, like taking a hash of a substring helps in this case. So like hmm, hash of okay. So hash of s of I to j. Okay, I will go here and explain. So what we do, hash of s is s0 plus s1 times p plus s2 times p square, and so on, so on, so on. So suppose this is a b c, and suppose this is x. Now we just want the hash of b and c. So the hash, only that part will be s1 into p plus s2 into p square in this hash. But in real, the hash of bc, uh, hash of I should different word. So s of 1 plus s of 2 into p. So hash of bc is equal to this uh, into sorry, divided by p. This into p is the hash of this subsum. So hash of si uh, go on till j into p of I, like here from b into c. So hash of suppose here p c string into p power 1 is equal to this sum of the locations, like s of 1 into p plus s of 2 into p square. this can be calculated as like we are given uh, like we will calculate one by one, right? Hash of s will be calculated like s of 0 into 1, sorry, s of 0 into 1, then plus s of 1 into p, plus s of 2 into p square, plus so on, so on, so on. So if we want just the 2, uh, we will we will store this in some uh, array. Suppose this is x of 0, this plus this is x of 1, this plus this is x of 2. So which is hash of s of 0 to j minus hash of 0 to I minus 1 mod m. So in C++, you will have to check if it's negative or not, or else it will give a wrong answer. Is it clear or not? Anyone can write in the chat box. I will repeat it if it's not. Okay. So, uh, I'm taking an example. A second. Like suppose I am given a string AABXAABXCAA, uh, and this is S1, and I have to find if XBA is there in this XBA pattern is there in this string. So what I know, the length of this is 3, and the length of this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This length of this is 11. So for all hashes, we can calculate like hash of S2, uh, hash of S of 0 to 2, hash of S of 1, 1, 2, 3, going till hash of S of some till n minus 2 till n. So we need to compare the hash of this. Suppose the hash of this is comes out to be lambda. So this is gamma, suppose gamma dash, so on, so on, so on, gamma n minus 3. So uh, so we will compare lambda with this all these numbers. So it will take O of n. Is it clear? Okay, so this was the Rabin-Karp algorithm, nothing else. Given a pattern P and a string S to check, but here we rely on a probability that uh, that the string will not collide. Like we take mod m, right? So it it can so happen there can be at most n strings which are non uh, collided, suppose. So there can be at most n strings which are not collided. Uh, After that, by pigeonhole principle, we can say that it cannot be that case. So we rely on a probability that it doesn't collide. So now we will look at a perfect solution to this problem. So KMP is nothing but a prefix function. Using KMP, we find a prefix function of a string which is denoted by pi. So what it is like a for a pi of 0, we take it as 0. So now uh, suppose uh, we look up pi value at this. So it is nothing but suppose I'm calculating pi value at ith position. So this so it is still suppose length x. So maximum x, uh, maximum not minimum x we can get like maximum length here, and not the whole string, such that this and this is same. This is the value of pi. Suppose we are given a, and we need to calculate the value of pi at the fourth position. The value of pi here is 3 because a here and a here matches. Is the prefix function clear, anyone? Like in this case abc, this uh, in this case this abc and this abc matches, so the pi value at the position is 3. Can anyone write in the chat box if it's clear or not? Like prefix is equal to suffix of same length. Yes, of same length and same, like a b c, suppose x and a b c, so this and this. So the maximum length we can find such that abc matches this abc. Okay, so I will take an example of how we will find it. A second. Suppose the string is aabx, aabx, c, aabx, aabx, ay. Suppose this is the string given. Now I will calculate the values of pi at each position. So the value of pi at 0th index is always 0. So I will first go through in a naive way. So the value of pi here will be 1 because this and this matches. The value of pi here will be 0. It will take a lot of time, but okay. The value of pi here will be 0. The value of pi here will be 1. The value of pi here will be 2. So uh, yeah, anyone wants to speak? Okay, so no one. So the value of pi here will be a AAB and AAB here matches. So it will be 3. Here it will be 4, and so on, so on, so on. We can notice that the value of pi do not the change in pi value does not exceed 1. So like suppose here this suffix and this suffix matches. Now we need to calculate a value of pi here. So we first check if this and this matches. So if it matches, the value of pi I will be value of pi I minus 1 plus 1 directly. Like suppose in here the value of pi was 2. So we don't need to check again at this position if A matches or not. We will check B and B, matching of B and B. So as it matches, we will just add 1 to the value of 2. Okay, so this is the first condition. Like if S of I is equal to uh, S of pi I minus 1. I think S of pi I minus 1. Yes, if 0 best index. Okay. So the next condition. Now, if it does not match, if the new character here and here does not match, we will take the inner, uh, like we have by dp we have calculated the values here, so we will take the pi value of this position and see if the I will make it clear, but a second. Like suppose AABX, AABY. So we know the value of pi will be 3 here. So as we can see, the y and x does not match. So we go here and see the value of pi in this position. The value of pi will be 0 here. I should take a. It will be better. So suppose AAAX, AAA, y. So value of pi here will be 3 and here it will be 0. So here it will be 2 now. So we can see that uh, before AAA and AAAY, AAA was matching. Now we can't extend it, so we take the inner pi value and use just this X AAAY. So we just use this and check if this is equal to this, which is not. So again we go to inner a x, which is not equal. So a y. So this and this is also not equal. So the value of pi here will be 0. So we go on de decreasing till we find such that the character here and here will be matching. So is it clear how we proceed? Okay, I will explain it again, I guess. So suppose AY and AAAY. Okay. So here the value of pi will be 1. Here the value of pi will be 1. No. Will it be 1? Yeah. Here the value of pi will be 1. Here the value of pi will be 0. 0 doesn't matter. So now we have to calculate the value of pi here. So we just check this and this are equal. So we just increase pi I minus 1 plus 1. This was the first case. Uh, the next case will be uh, this and this does not match. So we go to the inner pi value and check, like we don't need to check again if, what was that example, aabx y aabx, suppose it is z here. So we don't need to uh, again check all the characters. We just go to the value of pi here and check the next. Can anyone tell me, is it clear or not? Or can give me an example so that I can explain. Okay. A x a y. Okay. So the value of pi here will be 3. The value of pi, sorry, it doesn't matter. So the value of pi here will be 3. Suppose we know this by dp. So we know this block and this block matches. Now we compare x with y. So x and y does not match. So uh, we go to this block and and go to the inner the pi value of this position, so that we retain the maximum number of matches. So we go to the value of pi here will be 2, uh, so we check, we now check this position a. So now we will compare. We know this block and this block are in the contention of being the pi values. So now we check a with y. Now this also are not same. We go to the inner block of this, which is a, and here again we check a and y is not equal. So the value of pi here will be 0. I will go through the code and explain also. No worries about that. Is it clear, Divyendu, about that ax ay? Okay, cool. So we initialize p pi 0 is equal to 0. Then, as I said, we if like the example was a x a, suppose it was x. So here the pi value is 2. So we don't need to check again here and here. So we just compare x and x. So now they are same. We just keep the pi of I as pi I minus 1 plus 1. So the pi value here will be 3. So we first take j equal to pi I minus 1. In this case it was 2. So we keep on going till we find there is no such block which can be taken. Okay, so now we compare s of I. If s of I is not equal to s of j, we go to the inner block. Like I said, in this AAAX, AAAY, we now we know that X and Y are not equal. So we go to the inner block here. So we now check this A with Y in this block. So we uh, initialize, or we take j equal to pi I minus 1, pi I j minus 1. So we go on till we find s of I is not equal to s of j. Sorry, s of I equal to s of j. So now if s of I equal to s of j, we put the new value pi I is equal to j, and then go on repeating this block. Can anyone say if there is any doubt?
Can you explain it like with writing the positions of I and J, like dry running the code with an
Okay,
example?
okay, I can. Yes, that will be fine. X now, for this is always 0. We don't need to even check. So now at position 1, the j value is 0. We don't go here. Now we check s of 1 is equal to sorry, s of 1, yes, s of 1 equal to s of 0. So which is which it is, a is equal to a. So we increase the j and put the pi I equal to j. So here the pi I will be 1. Now for x, we put j equal to 1. Now j is greater than 0, and s of I x is not equal to s of j. So we uh, take j equal to pi, j was 1. So we take the pi value of this, which is 0. So j equal to 0. We don't go here as j is equal to 0 now. So if we check s of 0, sorry, s of 2 equal to s of 0, which it is not. So we don't increase j, we directly put 0. Now here, we uh, again we check, we put j equal to 0, like the value of pi previously. So now we go on. We don't need to go here because j is equal to 0. Now we just check s of uh, s of 3 equal to s of 0, which it is. So we increase j by 1 and put the pi value here. Now here, this case, we put j equal to 1, j is greater than 0, and uh, s of 4 equal to is equal to s of j is 1. So s of 4 equal to s of 1. So we don't need to go here. We see s of 4 equal to s of 1. We increase the value to 2. So we put pi I of 4 is 2. Now in here, uh, we go j equal to 2, as j is greater than 0. But here s of 5 is equal to s of 2, as j is 2 here. So we don't go here, we just go directly here, increase j and put the pi value 3. Okay, so how can this help us in string matching? So what we can do, suppose we are given a, uh, a string s and a pattern t. What we do, we create a new string which is s plus hash plus t, and then we check the, sorry, t, uh, a second. Huh. We are given a pattern s and a text t. So we this is a pattern and this is the text, and to check we calculate the pi I value of this new string, because now what we will do, suppose we have to check aax in a string baaxc. So we can now know the value of pi I here will be 3, which will match this pattern. So we can know that a pattern exists in this string, and we can also find the locations wherever pi I value equal to the length of the pattern, length of pattern, that is the location where we found it. So in this way, in O of n plus m, we can find a pattern matching. If it is not clear, can anyone write? I will proceed to z function now. So it is a bit like KMP, but not exactly. So suppose we are given uh, a string like this. The z value here we take it as 0 only. Now we check from like from here how many characters we can go that it matches the prefix. Like here we can go just till 1. Here we can go till 0 because x does not match a. From here we can go like aax, we can go till 3. Here we can go till 1. Here we can go till 0, and here we can go till 0. So this is the z function. This is the definition. Can anyone write if they don't understand or understand? Okay, so z function's definition is clear. Uh, Now how to calculate it? So suppose the string is aabx, aabx, c a a b x a a b x a by, suppose. So uh, the value of z0 is equal to 0 because it is not defined. It will just be, it will not make sense basically. So we just take it at 0. Now the pi1 value, I am currently writing the naive algorithm. Uh, so it can go up till just one character. So 1, here 0, here 0, here it can go up to 4. Like here. I will explain how we will do it efficiently. Now it is an n-square algorithm. For a position, we go up till how much we can go. So now here we can go just up till 1. Here we can go just up till 0. Here we can go just up till 0. Here we can go just up till 0. Here we can go just up till 1. Here you can go just up till 1. No. Here we can go a lot. Here we can go up till 8. and so on. Now this is the Z algorithm's definition. Now I will explain how we will do it. So on the same example, I have written the string. So this is the string. The value of I here will be 0. Now what we do, by DP we know all the previous values. So we keep an LR block of strings which which is matched. We name it as segment matches. So using the segment matches, we will calculate the next segment matches. So suppose now here we can naively check if A is equal to A. So here it will be 1. Here it will be 0. Here it will be 0. Now here we can go from this up till this. So this is the LR segment match I'm talking about. So in here we don't need to again check for all the rest. Here the value will be 4. For the rest, the value will be directly the values here, like 1 directly value here 0, directly putting value here 0. Is it clear, boy? Anyone can write, or I will explain again. Okay. So whenever we find this segment like L to R, uh, we can find it more easily, basically. So so the next here again, it is not in the segment match, so we have to calculate it separately. Here it will be 0 as A and C does not match. Now here it will be 8 and this segment will be quite big from here to here. So as it matches from AABX, AABX, so AABX, AABX. So now the value we directly put 8. Now here we can directly put 1 because this segment and this segment matches. This segment, okay, this segment and this segment matches. So we can directly put 1, we can directly put 0, we can directly put 0. Now here it's a question, can we put 4 directly? Can anyone guess yes or no? So someone wrote no, not clear. I will have to explain. Okay, can anyone say why can't we write 4 directly here? Because obviously the value is 5 by brute force. AABXAA, sorry, huh, AABXA and
But
AABXA.
maybe because of Y, there may exist instead of Y, there may exist AAB again. So
No, it's
is
not
it something?
that. No, like we are given a block of length this much. Now we can't put 4 because it goes outside the block. Like from A, uh, we can't put 4 because A plus 4 it exceeds the block. A second, is that the case? Okay. Yes, that is the case. So we directly can't put 4. So here till the block we can check if it's exactly in the block. So this is the case. For now we put 4, but now we check if this a is equal to this a. We check this, which it is, so we add 1, so we put the value of 5 here. So suppose in we calculate the segment match L to R. In this case it was AA BX AABX, and here what we have, the value is 4, so we know all of this matches. So we have to check the next character if it matches this and this. This is the cases. So here the value will be 5, like 4 plus 1, 5. This is the case. If anyone didn't understand, I will explain it again. Can anyone write yes or no? Should I explain?
If y was a, then would it have been 6 or 5?
If y was a, it would have been 6. We have to check. We will increase increase the segment matches. I will go through the code next, but is it clear till now? Okay. Saurabh, should I repeat it or is it fine?
Hello.
Huh?
Uh, yeah. The first part I understood. Then now you said of extending the segments, which was not clear.
Okay, so what I'm saying is, suppose I will write the same example, but a second. AABX, AABX, CAABX, AABX, AY. So the position where the problem was this. This was the segment then. Okay. So this was the segment. Now we know the value of pi here will be 8. Whatever the pi value here was, we will just put it here. Now, whenever the box matches uh, the segment, we will check the next character too. This is the case I'm saying. It is just an algorithm. Like we need to check the next element if it is equal. So we will go on till we check all the rest elements too. Is the case clear, Saurabh? What was I talking about? Like in this case, we again compare the next characters, this and this.
Huh. Huh. Okay.
Okay, so whenever the segment matches, we check the next characters too. So here A and A will be matched, so we put 5. So I hope the algorithm is clear. I will go through the code, what it was. Also, like the value of pi cannot exceed the length of the string, like uh, I plus pi I plus pi I minus 1 cannot exceed the string length, I guess. A second. Cannot exceed the string length, because we say like suppose a, and here we suppose say the value of pi is suppose 7. So it will extend the string and it will not make sense. So is it I plus pi I minus 1. This is the case. So this should not be. This is the, we will hard code it here. So the segment first, we talked about segment matches, right? LR. So we will first pi 0 will be 0, we will keep it. So the next character, for the next position we will calculate the LR. So if I is less than equal to R, means it is in the current string, we put it zi equal to r minus I plus minimum of r minus I plus 1, which is the limit it can take. Like suppose r here, it can take a we are taking the string, what was the name, segment matching, segment matching, segment matching up till here. So it cannot exceed that segment matching, so we take this head I for now, r minus I plus 1, and the value here, like we directly put the value 1 here, right? So we first calculated and we put directly 1 here. So we put zi equal to this value, and it cannot increase the segment match to. So now uh, while I plus zi less than n, because we put it like it cannot exceed n. So and z s of zi, s of zi means this, suppose it was aa and aab, suppose. So we check if suppose zi here was suppose 0, it will be 0. We check if a is equal to b or not. If it is, we increase the zi basically. If it is not, we don't increase. And now here we will change the segment. Like we said here, we took the value 5 instead of 4 because we check a and a here. So we took the value 5. A second. If we took the value 5, we will have to change the segment matching to this. So the new segment matching will be L equal to I and R equal to the, up to the extent it is in the string segment matching. Is the code clear to anyone? I will explain it with an example, but till now is it fine? Not quite clear. Fine. So I will take it with an example, I guess. AAPXA. Suppose a small example I am taking. I should take a bigger example only. AABX, AABX. That will be fine. BX, AABX. So here the value is 0. We put it directly. So now we put this segment matching as L equal to 0, R equal to 0 initially. Now if I is less than equal to R, means it is in some segment matching, we do this. Currently it is not in any segment matching, so z1 will be initialized with 0. So now we check 0 plus this is less than n, obviously 0 plus 0, sorry 1 plus 0 is less than n, and s of 0 is equal to s of 1 plus 0 because a and a matches, so we will increase zi. Now we go to the next character, s of 1 equal to s of 2, which is not, because s of 1 is a and s of 2 is b, so which is not. So and this is not the case, so we directly put 1 here. Now B. So the still the I is less than equal to R, so we do not go here. Z of 2 is initialized with 0. Now we check the first characters. S of 0 is equal to S of 2, which is not. So we don't go here and we don't go here. So it is directly initialized with 0. Now X at this position. So here we huh, uh, it is still not in any string matching, so we put Z of 3 equal to 0, and Z of 3 is equal to 0. It's still not going here. Now here we check Z of S of 3 equal to S of S of 0 equal to S of 0 equal to S of 3 or not. So X is not equal to A, so we don't go here, we don't go here. So it is initialized with 0. Now this is the main. So here it is still not in any string matching, but now it will go on matching like S of 0, this and this matches. So Z4 is increased with 1. Now A and A matches. So Z4 is also again increased with 1. This and this matches. So Z4 is again increased with 1. This and this matches. So Z4 is again increased with 1. Now the value is greater than equal to n. So it does not go here. So we put 4. Now I plus I Zi minus 1 will be greater than R, as position 4 plus 4 minus 1 will be greater than 0. So we take this segment. This is the new segment. So now Zi is in this segment. So Z5 is in the segment. So what we do is initialize it with 1. Initialize it with 1. Now we check now what do we check? S of number 5 plus, this is not the case. Now we go here. S of 1 is equal to S of position 1 2 3 4 5 plus 1. This and this is equal or not, which is not the sorry, A, this B, this B and this A is equal or not, which is not the case. So we do not increase Zi. Now this is not greater than R, so we don't go here again. So we directly put 1 here. Here we initialize it with 0. Now we check B 0, S of 0 equal to S of 7, I guess 6 or not, which is not the case. So we directly put 0, and this is also not changed. Here we directly put 0 in similar way. Is the algo clear a bit? Okay, fine. So I was just taking a 1 hour class today. I'm not extending it much. So if there is any doubt, you can write it in the Facebook group, and I will put some problems here for you to check your understanding. If there is any doubt, you can message me on Teams. I will, yes, I will provide the problem links. So if there is any doubt, message me on the Teams itself. So thank you for coming. Much appreciated.